Hi, and it's Coding Thursday with Fix It Gateway Security. Today marks it the 9th episode since we started this series. And the aim is to teach every passionate cybersecurity persons who intend to build tools for the open source community to get used to the fundamentals and concept of these various programming language we are teaching. So on today's topic, we'll be summarizing the operators, which is the assignment, relational, equality, logical, and bitwise. So these operators are very essential if you're going to be doing some algorithmic computation in your program, such as hashing or passwords or any other functionalities that requires these various operators to be used. Also, we'll be demonstrating a few code examples to display how to use these various operators and explain the concept of why the output that was gotten using these operators was attained. So without further ado, let's get started. So the summary of these operators we'll be dealing on today is the relational, the equality, the logical, and the bitwise. Under the relational, we have the greater than, we have the less than, and we have the greater than equal, and we have the less than equal. Then if we head on to the equality, we have the equal sign in C, which is designated with a double equals symbol, and we have the not equal, which is designated as an exclamation mark followed by a single equal symbol. Under the logical operator, we have the logical AND, which is designated as the double AND symbol, and the logical OR is designated as a double pipeline symbol. And for the non-logical or not logical, it is designated as a single exclamation mark. Summarizing it with the bitwise, for the bitwise AND, in C programming, we use the single AND symbol. And for the bitwise OR, we use the single pipeline symbol. And for the complement, we use the tilde sign. Under the complement, what it means is that if a statement is true, the complement of that statement is false. So it's like the opposite of a statement. Then we have the exclusive OR. Under the exclusive OR, we'll be comparing two values of binary numbers or bitwise value that has a true and false statement. So for the exclusive OR, also known as the XOR, if both statements are false, then the output will be false. If both statements are true, the output will also be false. However, if one of the statements is false and the other statement is true, then the output will be true. So to have a better understanding of the XOR, it means that one of the statement has to be the opposite of the other for it to be true. So let's say we have X is 0, which is assigned as false in bitwise operation, and Y is 1, which is assigned as true in bitwise operation. That means if we do the XOR of X and Y, we'll be having true, which is 1. For the shift right in C, it takes two numbers and gets their operand. The operand of the first number is shifted to the right, and the operand of the second number decides where it starts its shift. While for the shift left, it takes two numbers and gets its operand, and the operand of the first number is shifted to the left, and the operand of the second number decides where it starts its shift. To better understand shift left is that for shift left, let's say we have two numbers A and B, right? So when we shift the number to the left, the actual computation for shift left will be the first number multiplied by 2 power the second number. So let's say the first number is 2 and the second number is 4. So if we conduct for shift left, the computation will be 2 times 2 power 4, where 4 is the value of the second number and 2 is the base value that is powered to the second number. Then for shift right is the opposite. So instead of being a multiplication, it's going to be a division. So let's say we also have the first number to be 4 and the second number to be 2, right? So when we do for shift right, it's going to be 4 divided by 2 power 2, where the power 2 is the value of the second number and 4 is the value of the first number. So when we now do the shift right for that computation, we should be having 1. All this will be demonstrating with various code examples so you can understand what we're actually talking about. So here is a simple table or a simple chart where we have 6 columns and 5 rows. The first 2 columns has the value of X and Y. And as you can see, for the second row, we have X to be a false statement and we have Y to be a false statement. So when we do X and Y or the AND operation using these 2 values, we will discover that the output will become false. Remember, as we previously described, that for a statement to be true, using the AND operator, both statements has to be true. If one of the statements is false, then the output will be false. And if both statements are false, the output will also be false. So that's why we have for X and Y to be 0. And now if we head on to X or Y operation, we can also discover that we have false. Now remember also when we describe for the OR operator or OR bitwise operation in C, we said that one of the statement has to be true for it to be true, or both of the statement has to be true for it to be true. So OR is like not strict conditional. It's like variable conditional. So it's not compulsory for both statements to be true for it to be true. However, one of the conditions has to be satisfied for both statements to be true. One of the conditions are not met, then both statements will either be false. And also, if we move further, it doesn't matter if both statements are true. As long as it's OR, then both statements will be true. So in this case also, considering the second row, we can also discover that we also have a false statement because both statements, none of them satisfy a single condition. Now, if we head on to the last column, we can see the negation of X, which is also known as the complement, right? So in C, we know that the complement of a value is the opposite. So if something says good, the opposite will be bad. And if something says bad, the opposite will be good. And from the first column, we know that the value of X is false, right? So the complement of the value of X will now become 1. Furthermore, let's move on to the third row. We know the value of X is 0, which is false, and the value of Y is 1, which is true, right? Moving back to the explanation we previously gave, X and Y would be false because both has to be true for it to be true. X or Y will be true because one of the conditions were met, one of the statement was true and the other was false. So we have a true. And if you go for the XOR operation, remember both statement has to be opposite for it to be true. If they are the same, it's going to be false. And if we move down to column 1 and column 2, we can see that X and Y are opposite under row 3 of 0 and 1. So that's why we have the XOR operation or the XOR operator to be 1. Now on the last column, on the third row, we have X to be 1. Remember also the complement of X is the opposite. On the third row and last column, that's the reason why we have X to be true or 1. So let's move on to the last row since the fourth row still is the same. X is true and Y is true. Now, if we consider the AND operation, both X and Y has to be true for it to be true. And that requirement has been satisfied. And that's the reason why we have the value of 1 under the third column. And X or Y is also true. It doesn't matter if X is true or Y is true or both X and Y is true. As long as one of the statement is true, then it will be true. And if both statements are also true, it will be true. That's why on the fourth column, the last row, we have X or Y to be 1. Now, heading on to the XOR operation or the XOR operator, we have X XOR Y is 0. Also remember, one of the statements has to be false or they have to be opposite of each other for XOR to be true. But in this case, both X and Y is true. And we now did the XOR operation. We have X XOR Y to be 0 or false. And on the last column, now the X column is true on the last row and the first column. So the complement will be the opposite. Now gives us false. So let's now demonstrate this using various code examples and show you in terms of mathematical computation using C program, how this can be displayed in the output when this program is run. So we get our code blocks fired up. And as you can see, we already did some binary computation here to explain these examples to you and show you what really is going on in the background in terms of doing the mathematical computation or algorithmic computation using logics or binary operation in C. So let's start with the relational. Let's say we declare a data type of integer and we call it fixit1 and we assign it a value to be 4, right? Then still the same data type, we call it fixit2 and we assign it a value of 5 and we terminate the program with a semicolon. Now to explain the relational, so we'll be dealing with the greater than, the less than, the greater than equal, and the less than equal, right? So let's now introduce a single if statement and one else statement. Now, the comparison is always from left to right whenever you're using the relational. So it moves from left to right. The first value or the first variable name that is being compared will be on the left, and the second variable name will be on the right. So in this case, we're talking about fixit1 and fixit2, right? So let's say we want to do for the greater than. So we can say if fixit1 is greater than fixit2, then we'll say printf, the statement is true, and the value of fixit1 is, so we do spacing tab and we'll say %d as the specifier for data type integer, and we give a spacing and we put it in a double line because we want to put the value of fixit2 as well. So fixit2 to be also the value, right? And we also indicate the specifier for data type. And the reason why we did twice here is because this statement here is like also saying this, and we end this with a semicolon. But remember in our previous examples, we said if you're assigning the same data type, there's no need of you declaring multiple integers. You just declare a single integer and assign the various variable name, their various values they hold. So that's the reason why we have %d here, %d here, just to make the program very easy. So let's put this also in a new line. So our program will be beautiful. Then we come here, we say comma, and we say fixit1 and fixit2. Remember, we're dealing with two numbers, right? Sorry, we're dealing with two variable names. So we come here to print this. So let's just copy this. No need to write a long statement. And we come here, we just put it here. We just change it to false. The statement is false. Now, let's now explain this code. Here in code line 35, we're saying if the code line 32 requirements are satisfied, then print it to be a true statement and also print the variable names and the various values or numbers they hold. And if it's false, sorry, we can remove this here. So if it's false, then let it print the second statement. So if we go back to line 27 or code line number 27, we can see that fixit1 is 4 and fixit2 is 5. So by this logic here, we know that this is false. So when this program runs top-down approach, it's going to read the statement of 35 and say, okay, this is not okay. So this is what we are going to print because this is less than this and the comparison is in terms of greater than. So let's build this right now to show you the output. Okay, printf, not pref. We build this again, run printf. Now, when we run this program right now, we should be getting false. So the statement is false and the value of fixit1 is 4 and the value of fixit2 is 5. Because by the logic, it has read code line 32 and comparing to the value that the variable names hold, it discovers that this is not true. So let's skip line 35. That's what the program will say. And let's now print line 40. So let's go back here. Let's say we change fixit1 to 14 and we still leave fixit2 to the 5. So logically, we know that now fixit1 is greater than fixit2. The output of this program will now become true. The statement is true because when the program checks or does the checking, it discovers that, okay, truly, fixit1 value is now greater than fixit2. So I would print code line number 35 and ignore the rest of the program if I don't have to do any further checks. So if we build this right now and we run, we should be having a true statement. This statement is true, and the value of fixed1 is 14, and the value of fixed2 is 5. So that's just using the greater than sign, right? So let's now introduce the less than sign. We still leave the statement, right? And we say if the value of fixed1 is less than fixed2, print the statement is true. Else, print this is false. So it's still the same thing. We are not going to change the program. The program will tell you that, okay, I will do the checking right now, logically, but it seems that fixed1 is greater than fixed2. But the computation here is telling me that if it is less than, then I should print the code line 35. And in this case, I have done the check-ins and I have discovered that this is not true. So I will skip code line 35 and I'll head on to code line 38. And if there's no further check-ins that I have to do, then I will print the statement that is assigned there. So if we still run this right now, we should be getting this statement false. And we run, statement is false because by the logical representation, fixed1 is greater than and not less than fixed2. So that's it with less than. Very simple. It's not difficult. You just have to understand how you apply your logic. And remember, it's always comparison from left to right. It's not from right to left. The check-ins of the relational logical operator always from left to right. So now let's put for the greater than or equal to. So let's say greater than or equal to, right? So what does this mean? It's still the same thing. The only difference is that we just inserted the equal to. And why do we use this logic? Let's say we want to get a value from a user, right? And we have a range of comparison we want to do, in the sense that we want to make sure that if the value that the user supply is greater than or is equal to the base value that we have declared, then okay, the program should run. However, if that is not met, then the program should skip. In this case right now, we are saying that if fixed1 is greater than or equal to fixed2, right? Then the statement should print is true and print the value of fixed1 and fixed2. Else, let it print the statement is false. So in this case right now, the statement will print true. And you might ask why? Because the value of fixed1 is greater than fixed2 and it's not less than. But if the value is also equal to fixed2, it will also print the true statement, because the condition here we are saying is that if it's either greater than or it's equal to fixed2, then I want you to print that the statement is true. But in this case right now, we are not changing it to an equal value. We just want to run this program so you can see how the greater than or equal to sign works. So when we execute this program right now, we should be having a true statement. So if we build right now and we run, now you might ask, why do we have false and not true? Because by the logical representation, we should use the top-down approach. So the false should come first. So if the program is false, we should see the program to read the false statement first before reading the true statement. Remember, a program is from top to bottom. It reads the first command, then moves on to the second command. And because of our logical representation is not okay, that's why we are reading or we are getting the value of false, because logically we know that fixed1 is greater than fixed2. So in this case right now, we can just come here and copy this, or we cut this content here to obey the law of top-down approach, right? And we copy this here and we put here. So logically right now, we have satisfied the requirement for top-down approach, and which is false if it's not, and if it's true, then skip and print true. So when the program now runs right now and checks fixed1 and said, okay, truly, this is true. So this code line 35, I have to skip it and I have to move on to code line 38. And if there is no other checks that I need to do, then I have to print code line 40. So this is the logic of top-down approach. The error message has to come first before the true statement. So if we build right now, our program should run completely right, and we should be having the true statement. So you can see now we have the statement is true, and the value of fixed1 is 14, and the value of fixed2 is 5. And if we come here right now, logically, we can now say that this is actually true, because fixed1 is greater than or equal to fixed2. And if we close this right now and we do for the less than, So this is less than or equal to. So for less than also, we have to do the interchange because the false statement has to be up here, which is this one, this true statement, or the true statement comes last. So if this is less than or equal to this now is not considered to be true in the real sense. The false part is the error message because we know that fixit 1 is not less than fixit 2. So this has to come second. So we cut this down here and we cut this first one here and we put here. So when it does these checks, it will check the variable name and the value it holds. Is it less than the second variable name value? And it says no. So this statement is not true. It will now skip and check this. So if we run this program right now, we should not be having any errors. But less than or equal to. And let's build. This statement is false. You can see because we know that fixit 1 is not less than or equal to fixit 2. So that's how to use the less than or equal to. Now, to buttress this whole jargons explained here right now, let's now make fixit 1 to be equal to fixit 2 so you can understand. So if we come here and we say, is it fixit 1 is less than or equal to? So we know that fixit 1 and fixit 2 are not equal. The output will be true because it's less than and it's equal. Sorry, because it's equal. So it has checked for less than, it's not, but it noticed that both are equal. So this statement is true. And if we run this program right now, we should now be having the true statement and it will skip code line 39 down to 44. The statement is true because both numbers are equal. So it checks for less than and said, no, it's not less than, but somehow it's equal. So this is actually true. So let me print a true statement. And if we also change here and we say greater than, it doesn't matter. It's still going to print true because both data type and variable names hold the same value, which is 5 and 5. So we'll still be having true because fixit 1 is not greater than, but somehow it checks that, okay, but fixit 1 is equal to fixit 2. So this statement is still true. And if we build this right now and we run, and you can see the statement is true. And if we come and we say, we change this to this, and we run, say the statement is false because it has done the checks and discovered that fixit 1 is less than and it's not greater than. It's also not equal to. So this statement is false. It checks for the greater than and said no, fixit 1 is not greater than, and also check for equality. It's not equal to. So it says, okay, this program, whole logic I have checked is false. So let me skip this code line 36 and move on to code line 39. Now, if there are no further checks, okay, I will now print 43 and I'll terminate the program, which is the return 0. So return 0 is basically just end program. Some people would put a print statement here. So it's just, so you can say return, let's say, printf. Sometimes you can write a function and call it here, end program. So, okay, let's build. If we run this here, you can see end program, you can see. So it's here already. So 0 is just the logical representation of end program return 0. So if you don't like the output of 0, you can just come here and put printf statement to tell you that this is what the program, is done. You can just put a new line here. So it ends the program. So ends program. So if you don't want to use 0, you can just remove the 0 and put custom message there you want. So that's it for the greater than and less than, equal to. So let's move on to equality operator in C programming. We still retain this. For the equality, we're going to deal with the equal, and the not equal to sign. These are the two operators we'll be dealing under the equality operator in C. So let's remove this and we put the double equal. That's how to represent the equal sign in C. And we say if both variable names hold the same value, then let it print the statement is true, else let it print false. So here we don't need to do any interchange. We just leave it this way because we are dealing with equality, right? So if we build right now, we should be having a false statement and end program. So if we run right now, you can see the statement is false and it tells us the value and it ends the program, right? So let's now come back here again. Let's say this is holding 5. So now we know both variable names hold the same value, right? So if we build right now and we say yes, and we run, and we'll be having a true statement. So the statement is true and both variable names values or data is displayed to us. So that's how to use the equality sign in C programming. You have to understand what you're comparing to and what is being compared to if you want to use the equality sign. Understanding this various logic is very important. You cannot be comparing between two, let's say one value is higher or lower than the other, and you're now using the equality operator in C to print a true statement. It doesn't work that way. So the logic in this case, depending on which side of the variable name holds the higher value or number, we can now decide if we want to use the greater than or less than, or the greater than equal to, or the less than equal to. Just understand the concept of how these various operators work. So at each concept of your program design or building your tools, what operator can you now apply to that logical angle of your program or to that logical line of your code? So if we understand these various concepts, we now know how very, very straightforward and beautiful we will design the concept of our program and also avoid errors due to debugging. Which of the statement comes first? Is it the false statement or the true statement? Or is it the true statement or the false statement? So these are the various concepts you should understand when using these various operators in writing codes in C programming. It's not difficult. It's not complex. Just understand the fundamentals of how these operators are to be used and in what case should you apply these operators when building your tools or when writing your codes. So if we come here right now, let's now deal with the not equal to. We'll remove one of the equal sign and we'll put the exclamation mark. So let's put this, let's say this is 1. And now coming back to our code, we said if fixit1 is not equal to fixit2, so the statement is true, else print is false. And as you can see, the top-down approach is to check for the true statement false, right? So it means that, okay, I have checked this right now. Truly, fixit1 holds a lesser value and fixit2 holds a different value. So both of them are not equal. So this statement is true. Else, I'll have to print for the tree if it's false. So if we run this right now, we'll still be having true because fixit1 is less than fixit2 and both values are not equal. So let's build and we run and you can see the statement is true and the value of fixit1 is 1 and the value of fixit2 is 5. So let's close this right now. Let's also show you the concept here, right? So let's say we make both values equal. Now, remember also the top-down approach, the true statement has to come first, right? So in this case, it's false because both values are equal. So we cut this and we put here and we cut this and we put here. The reason is whenever a program runs, it reads from the top to the bottom. So the true statement has to come first because that's the statement it has to read to check if it's actually met the requirements of the logic. So if it's not okay, then you say, okay, I have to discard this. This doesn't make sense to me. So let me move on to the next line of code and see what makes sense to me. So if what is in the next line of code makes sense to me, then I can now say, okay, this is cool. I have to print it out to you because that's what is being fed to me, or that's the logic on which I operate on. So if we run this program right now, we know that both variable names hold the same value, which is 5 and 5, right? So code line 34 will be skipped here because the statement is false in the sense that both of them are equal. And the logic here is saying not equal. Then it will now move on to code line 39 and check if there's any other logical checks it has to do. And if there are none, it will now print code line 43 and it will end the program. So if we build this right now and we run, this is what we are going to be having, the true statement and not the false, because both of them are equal. So you can see the statement is true. The value of fixit1 is 5 and the value of fixit2 is 5. So that's it with the equality in C programming. It's not difficult, like we previously said. You just have to understand the concept, the fundamentals, and how to use this logic. The importance of the fundamentals is the reason why at Fixit Gateway Security, we started this learning the basics in various programming language, so that by the time you start building your own tools, you wouldn't, find it difficult. Or by the time you get our paid courses on C programming, which is the course we'll be publishing this year, you wouldn't find it difficult to understand the various concepts we'll be explaining in details. So now that we're done with the equality, let's now move on to the logic.